Okay, Module 2, Lesson 3, Evaluating Expressions. The learning goal here is to evaluate algebraic expressions. How you'll know you've mastered today's content is you'll know that an expression describes a computation in general terms to be applied in specific instances. So we have a general expression that we can plug things into when we need to evaluate it or find an answer for a specific instance. Then understand that an expression is a statement that describes a relationship between data, and evaluate algebraic expressions for a given value. So we have to know it and we have to be able to do it. Okay, so for this one, we're going to need to know how to use order of operations. So this is the background knowledge that we did in one of our previous lessons. Order of operations, super important here. You have to know what order to solve these things. So per order of operations, I know I'm going to look at my problem from left to right and go through looking for grouping symbols first. So left to right, I see this bracket. This is my grouping symbol. Everything within it, I have to go through first. And then again, I have to follow order of operations within these grouping symbols. So even inside of here, I look for grouping symbols first. So here I see from left to right, 5 minus 1 in parentheses. I have to solve that first. 5 minus 1 I know is 4. And there, 6 plus 8 times 4 in brackets. So since I'm still in my brackets, I have to multiply 8 times 4. I know that is 32. And now I can just figure out what this is. 6 plus 32, I get 38. That is my evaluated expression with the use of order of operations. Now looking at the vocabulary, order of operations, so the rules which state the order calculations are to be completed in an expression. So, right, parentheses, then I go to exponents, then multiply, divide together. This is one step. And then I add and subtract from left to right. This is one step. An expression, so numbers, symbols, and operators such as addition and multiplication grouped together that show the value of something. Like this, 4x minus 7, that is an expression. And here it kind of shows the difference between expressions and equations. You can already know it just from listening to the word equations, right? It has the prefix that means equal. So the only difference between these are equations have an equal sign to them. Expressions, you can only simplify them unless you know the value of the variables that they use. Here in equations, if you have an expression set equal to something else, making it an equation, you can use whatever it's set equal to figure out the value of that variable. So here we have 5y plus 3, that's an expression, and then 5y plus 3 is equal to 8 is an equation. Substitution, so replacing variables with the value of the variable. So substitution is the first step in evaluating any expression. First you take like 5x plus 3y equals 7, and then we find out the value of y is 4. So now you can replace that y with the number 4 because we already know its value. Same thing over here, x plus x over 2 when we don't know the value of x. Then when we find out x is equal to 5, we can replace the x's and write 5 plus 5 over 2. It's a substituted form. So here, evaluating to calculate the value of an expression. So here the expression is 6 plus m, where we don't know the value of m. Then we find out m is equal to 2 and we substitute. Now that it's substituted, we can then evaluate, right? 6 plus 2 is equal to 8. Over here, it's the same thing. 3 minus x times 1 minus 2x. We know that now x is equal to 2. We replace the x's with 2's. And then use order of operations, right? We start with the parentheses, solve what's in there. We get -3. Then left to right, look for multiplication division. We multiply these, get -6. 3 minus -6 is the same as 3 plus 6. And then we finish evaluating to get 9. You're always going to use order of operations to evaluate your problems. The concepts for this lesson are evaluating algebraic expressions. So an algebraic expression is a mathematical statement that describes a relationship between data. So expressions are statements. More specifically, it describes a computation, right? So in general terms, that is to be applied in specific instances. So these are general setups that we can then plug into them to get the answers for specific instances. For example, if I have the expression of like b plus 4 representing my age. So my age is going to be described by b plus 4 being my brother's age at any given time plus 4 because I'm 4 years older. So if I say the expression representing my age, and this is relating some other piece of data to my age being I'll say using my brother's age. So how do you calculate my age? It's b plus 4. However old my brother is plus 4. So if I say right now my brother's age is 22, now we can substitute into here. I know what b is for this particular instance. I'd figure out that my age right now is 26. And if I say next year, if I was doing the same thing, when my brother turns 23, let's say, well, 23 plus 4 equals 27. Next year, I'll be 27. So these are particular instances, but this is the general expression that represents that relationship between data being my brother's age and my age. Okay, so sometimes instead of leaving an expression in general terms, you will need to evaluate the expression for a given value, just like we just did for those two instances, those two given values. You'll be given a value to substitute into the expression for each variable when you're told to evaluate. So you don't have to be scared, like, how do I evaluate if I don't know what number I use for that variable? They have to give you that if they're telling you to evaluate. When you substitute the number into an expression in place of the variable, you should always use parentheses. So for example, here, whenever I plug in a number for b, I should use parentheses around it. That helps a lot when we are going to use numbers with exponents and negative signs, just to keep everything in order and so you don't lose anything. Once you have performed the substitution, evaluate the expression using your order of operations. So here, first example, we're going to evaluate that expression when a is equal to 3. So here's my general expression. 6a plus 2 is my general expression. And we're going to evaluate it for the specific instance when a is equal to 3. So now I'm going to take everything that's not my variable, rewrite it, and in parentheses, I'm going to replace my variable with whatever it's equal to. Here it's 3. Now that I've substituted, I can evaluate using order of operations. So 6 times 3, that's 18, plus 2, I add 2 to 18 to get 20. So that's evaluating when a is equal to 3 for the expression 6a plus 2. Next one. These are just going to get a little more difficult each time. Evaluate negative x plus 4 plus x minus 5, parentheses, all in brackets, when x is equal to negative 3. This is when it gets really important to use parentheses for our variables. So I'm going to rewrite this, and I'm going to put that negative 3 or x in red so you guys can see the difference. Okay. So I know that this is all the same. I have negative, and I'm going to plug in here whatever x is equal to. And then I'm going to add the 4 plus blank minus 5. This here is going to be another instance where I put in whatever x is equal to, right? So here is where x goes, here's where another x goes, and both of those are negative 3. We're told they are equal to negative 3. So now I just use my order of operations to evaluate. I'm going to write this in a different color too. So left to right, looking at this, I see my grouping symbols, the brackets, and inside of them I see another pair of grouping symbols, these parentheses. So negative 3 minus 5, that's what I do first, negative 3 minus 5, that altogether makes negative 8. 4 plus negative 8 left in my brackets, and outside I have negative 3 being added. 4 plus negative 8, I have more negatives than positives. That's going to mean I have 4 more negatives than positives, so negative 4. And that, now that it's the only thing, I can take it out of my brackets. And now from left to right, I start with, let's say this is multiplication. A negative times a negative will give me a positive 3. I have 3 plus negative 4. I have more negatives than positives. How many more? 1 more. So from all that, of what we started with up here, at the instance where x is equal to negative 3, I get negative 1 when I evaluate. Sometimes we're going to need to substitute values for more than one variable and use fractions and or decimals. So here we're going to practice a little bit with more than one variable. I'm going to write the general setup and replace each variable with a different color so you guys can see when I'm using each. Here I'm going to put C in green, and then the rest is going to go. Let's say A is going to be in pink. Minus 2 times B will be in orange. So this is my entire expression. And we have A is set equal to 1.1. So there's our decimals. B is equal to negative 5.5. And C is equal to negative 2.2. So I'm going to rewrite this, and I'm going to plug in negative 2.2 where C is at the beginning. And we see that that C value is being squared, so I have to square the number that C represents. And then in parentheses, I have to plug in my value for A minus 2 times my value for B. So 1.1 minus 2 times my value for B, which is negative 5.5. So here I have my general expression, the specific instances, and then it's in that expression using substitution. And now I can evaluate using my order of operations. So from left to right, I see these parentheses with an operation inside of them. There's actually 2 operations. Here we have subtraction and multiplication. Order of operations tells me to do the multiplication first. So -2 times -5.5, that will give me positive 11. So now I can have 1.1 minus positive 11. Oh, actually, negative times negative is a positive. So this will be replaced with an addition sign. And altogether, because this is still in my parentheses, I do that before I do my exponent. So I have to figure out what this is altogether. And that is 12.1. And that is going to be multiplied by -2.2 to the second power, because now there's no operations in my, what's it called, parentheses. So it's just multiplication now. 2.2 squared is 4.84. And since it's a negative squared, negative times a negative equals a positive. So this is positive 4.84 times my 12.1. So next step, times 12.1 gives me 58.564. Okay, that is that example. Now we have another one with multiple variables. But what this question is asking us to do is model the math that goes along with this situation. So it's your turn to buy the snacks for the team for the soccer game. You purchased 22 sports drinks that cost $175 each. All right, so let's say we buy 22 sports drinks and they cost $175 each. I'm going to multiply those. That's going to give me the total cost of my sports drinks, right? I bought 22 of them. They're worth this much each. That's how much I have to spend on each of them. So I have to multiply those numbers. And I add what I have to spend on sandwiches. Sandwiches we'll say is in green. So 10 sandwiches that I bought for $2.50 each. That gives me the total I spent on the sandwiches. And add, I ran out of room, but whatever. My 8 bags of chips, that cost me 50 cents each. So if I add all those together, I get what I spent on all the snacks. The way I can write this for in general, if I want to find out how much I spend at the next game, if there's like more people or people want different things than they did the first time, is I can set this up as, let's say, S for sports drinks now, multiplied by how much I spend per sports drink. And I'm going to add, let's say for this one, sandwiches, dang it. What can I use to represent sandwiches? Let's do B for bread. Sandwiches would be B for bread. And then that's going to be multiplied by how much we spend on the sandwiches. Plus, we'll use, let's say for this one, we'll use C for chips. That's going to represent how many chips we buy that time times how much the chips are worth. So now we have a general setup, right? This is specific instances when we bought 22 sports drinks, 10 sandwiches, and 8 chips. This is what I can use to figure out how much I'll spend for any game, right? However many snacks we want to get, I can figure out how much it's going to cost just by using that general form.